Hello everyone, my name is Karthik Kumar Pandya and this is my second conversion piece for CSC 120. So for this project I designed a 2-bit stopwatch counter with a save left memory feature using sequential circuit in Logisim. The circuit can start and stop counting, reset to 0, save the current value as left and display the result as on a 7-segment display. This project extends the sequential logic concept we studied in class and combines counters, memory registers, multiplexers, and display decoding into one complete system. The goal of this project was to create a small stopwatch-like system. The circuit includes 4 inputs: clock, start, stop, reset, and save left. So the main 5 functions are counts in binary from 0 to 3, pauses and resume counting, resets all memory to 0, save the current count into memory, display either the live count or the saved left value. So the circuit divided into 4 major sections. The first section is synchronous uh, counter built using 2 T flip-flops. The second section is left memory register built using 2 D flip-flops. The third is BCD 7-segment decoder that converts selected binary into a digital system, and these sections also there is a multiplexers to select between the live counter value and the saved left value. Together these sections create a working stopwatch the memory. So I was just want to display how it works, so let me just start. So it is just let me start the auto click. Yeah, so you can see the stopwatch started 0, 1, 2 and 3, and it again come to 0, 1, 2, 3, and when I stop the whole system just stop even the clock is ticking. When I say reset, resetting, and when I do save lab, it doesn't do anything when this. So when I do start, it starts. If it is on a 2, if I save the lab, it will be saving the lab just the previous clock, so it's 1, and the clock is still clicking. And when I release the lab, it will show me the next clock value. I'm gonna show it to you. Auto click is off. You can see here it is 2, and when I do save lab, it stores 1, the previous clock value, and when I do it's 2 and it's 3. And when I release the clock, it will be show the value, how many clock I have just ticked it. So, and when I do reset, it will just reset the values. Yep. So basically what it does, so now it is 2. When I do save left, it saves the previous clock value 1. So let's assume it's on 2, and when I do 1 click, now on 3, now it's on 0, and when I release the clock, it should show 0. It shows 0, and when I do clock, it will just continue clocking, and I do save lab, it's, yeah. So that's how the circuit works. So this project helped me better understand how sequential circuits use memory and timing. So this project demonstrates a complete sequential digital system that functions as a simple stopwatch with a save lab feature. It combines counting, memory control logic, and display decoding into one integrated design. And I just wanted to give you the brief about the flip-flops. So the T flip-flop the reset input clears both T flip-flops and returns the counter to count to 0. So the lap memory function where I use the D flip-flop, these flip-flops act as a memory register that stores the lap value. And after the two additional multiplexers, select which value will be shown on the display, and the signals DQ1 and DQ0 are connected to BCD to 7 segment decoder. Because the system uses only 2 bits, the upper 2 BCD inputs are listed at to 0. So basically that was it from my side. Thank you for watching the my conversion page 2 video. Thank you. Yeah.